Excellent. Hi, everybody. My name is Lawson. I'm a principal domain solution architect working for Red Hat. I've been at Red Hat for 9 years now. Before I worked at Red Hat, I used to actually work for a living. I was a software engineer for the government for about 25 years, writing some interesting software that's probably on your phone at this point. Today, I want to talk about next generation microservice development using Knative Functions and cloud events, which is a bit of a wordy subject. The reason I get really excited about this is that this is the kind of technology I wanted 10 years ago. Unfortunately, now I'm in a situation where I can't use it, and you guys can, but I'm the guy that unfortunately has to sell it. But I'm really, really, really excited by this new stuff that's come out, especially around the Knative Functions side. I'm going to give you some slides first of all, and then hopefully the demo gods won't kill me, and I can show you a demo of this stuff working. I've given this about 3 times so far, and the demo's never failed, so that's an obvious indication it's going to fail this time. So, we'll start with these. Bit of buzzword bingo time. There's not too much buzzword bingo in this one. I'm only going to be talking about Knative Serverless. I assume everyone here knows what Kubernetes is, what OpenShift is, and what all those kind of things are. Set the stage, where we are, where we were. The concept of legacy applications, more or less adverse to agility. Now, basically, this is describing where we were 10 years ago, building huge applications with all the functionality within it. When you wanted to change something, you had to rebuild the whole thing, had to redeploy it. And that was the kind of thing that made it adverse to agility. You couldn't change little aspects of it. Everything had to change at once. And these huge monoliths, and to be honest, we all love these monoliths. You know, they were our babies. They were the things we made an effort to actually build and lived and died with. Where we are-ish, and I say where we are-ish because this is where we'd like to be right now. The concept of functional decomposition would have moved to microservices, where you could break those legacy applications down into multiple little components. You could change those components without affecting the rest of the system, which means you could build them separately. Moving to sausage machines, and that's this kind of concept of cloud native, where you build an application where everything is injected using dependency injection. And these sausage machines can survive to being destroyed and being recreated because all of the information and context is actually held external to them. And it's a deluge of new technology and approaches. And I don't know about you guys, but every day I get up and look at the web or look at the emails I get, and it's full of names of things I've never heard. You know, and I used to, when I was bored giving sort of speeches to customers, I used to drop random things in that didn't exist just to see if they could detect it was. I got caught out with one customer because I was talking about a new way of building APIs called Apache Foreskin. So I don't do that anymore. Where we want to be. Now, this is the key thing about today. So this on-demand instantiation of microservice. Now, what I mean by that is when you break something down to microservices, when you build a system using microservices, in the current way of doing it, the current architecture, for example, with containers, they have to be active all the time. Now, the good example I give of this is, let's say you've got a system that's got 10 microservices. Then one of your microservices is called every second. The other 9 are called once every 24 hours. If you're standing that up on, let's say, Kubernetes today, you need 10 active pods, because those pods need to be there when that traffic comes in, even if it comes in once a day. So you've got your system, which is 10 microservices. In actuality, it's 10 pods that are running all the time. And those 9 pods that are called once a day are consuming resource for the entire day. Now, the whole concept of Knative Serverless is you've got this ability to actually instantiate an application via a pod and then instantly scale it down to 0. And that sounds like, so what? That doesn't make sense. What Knative Serverless actually does is it retains the ingress point. It's got a special ingress controller within the OpenShift system, within the Kubernetes system. And when traffic actually arrives at that ingress point, it respins up the container. And it's an almost instantaneous respin. So what that allows you to do, effectively in the example I was talking about, is have 10 microservices, 1 up all the time, and 9 in Knative Serverless state. So for the majority of the day, when you've got the system up and running, you only have 1 pod running. And the other pods only pop up when they're needed. So as there are no Red Hat salespeople in the room, because I always get told off when I say this, it means you need a smaller cluster. You don't need these huge clusters. You can have a smaller cluster because you're only using the resources when you need them. And that helps with efficiency. And we're all about efficiency at the moment. We've also got this concept called Knative Functions, and this is the new stuff we've been working on. If anyone actually saw the Summit demo we did earlier in the year, the Red Hat Summit demo, it was all battleships on your phone. I wrote the entire back end for that using Knative Functions. And Knative Functions are basically a way that a developer can build these functions without having to know Kubernetes. It does all the wiring for you. It sets up all the Knative stuff for you. You just have to write the code. And then you run a command called func, which is part of the kn function, which actually builds the image, deploys the image, and does all the wiring to make it a Knative serverless one. And that's the point of Knative Functions. That's the big thing I'm going to talk about today, which makes it much easier to actually use this new style of technology. But enough blurb, because I know we're all developers, and I've given that first bit of the speech 1,000 times. So let's talk tech. I love the way that this works, and I love it because it's simple. I've been a Java programmer since 1996. I was a Java programmer that was called Oak, if anyone remembers Oak. I am older than I look. And this, I've always had problems with understanding the complexities of things like Kafka and AMQ and streams, and it all seems like a massive overhead for I just want things to happen. With cloud events, which underpin the technology I'm going to talk about today, it is incredibly simple. You have the concept of a producer. That producer creates what we call cloud events. A cloud event, and I'll describe it on the next slide, but I'll give you a quick overview now, is a very, very simple payload and a set of headers. And that's all it is. In actuality, and I'm going to show you the cheat behind the scene, the broker itself you can talk to by posting a simple post request to. So you don't have to understand APIs. You don't have to build all those kind of complex interactions with Kafka and things like that. I'm not dissing Kafka. As of this morning, I probably understand Kafka for the first time in 3 years. And one of the wonderful things about these brokers, which are actually the central point the cloud events are actually handled in, is you can put backers on them. And I'll show you the example I'll show you will be a basic one that's ephemeral. And this broker just sits within OpenShift itself, receives the events itself, and then sends them on. But you can back them with things like Kafka. And the difference is, if you've got an ephemeral broker, any cloud event coming in is forwarded on. I'll explain how we do that in a second, and then it's lost. With a Kafka backing, you can actually resend previous events. So it's for things where you want a system that has persisted state that is dependent upon temporal activity, where you don't want to lose it. You can have a backer on it that's based on Kafka, basically. When the event is pushed to the broker, you have what's called triggers. And triggers are triggered by the type of the event. It's one of the header fields. And that type basically allows you to push the event to a consumer. And it is as simple as that. And what's nice about it, because it's based on the Kubernetes side and because everything is abstracted into specific Kubernetes objects, the triggers are independent to the consumers. So you build the consumer receives the cloud event, it works upon it, it does whatever it wants to do. But the actual triggers themselves are Kubernetes objects. So they're very easy to create, they're very easy to change. So you're not bound by configuration in the same way you are if you're building an event-based system based on messaging and based on things like Kafka. It is very simple, and I like simple. And the reason I like simple is I like writing code to do things. You know, I don't know about anyone else in the room, but I'm getting tired of writing 90% boilerplate code. You know, I want to write code that does fun stuff, and I don't want to worry about all the wiring. And this takes that worry away. So the anatomy of a cloud event, I said we get a bit techie at this point. That URL at the top defines it in detail. It's a very simple specification. That specification hasn't really changed since we started developing this. There's been a couple of changes based on some feedback. In fact, some feedback I gave in terms of the information that's needed by the broker. But it is a pretty stable specification. It's a very simple specification. And to put simply, it's just a blob with encoded attributes and a payload. And that payload can be anything. And this is one of the things I asked for when I was talking to the engineering team about this. What they used to have was the payload was JSON or other defined formats. And I'll tell you a little story about this. What they built was they built some libraries you could actually use as part of the API on the consumer side to handle the events. And one of the actual libraries was a JSON decoder. And what would happen was if you push the JSON as the payload, and that JSON was slightly wrong, because who writes JSON right the first time? It's always wrong in some way or other. It would fail the conversion, and it wouldn't run the consumer. So the actual conversion of the JSON into a bean is done, and if that fails, it stops the consumer. And I don't like that, because in the real world, you're going to get blips, you're going to get byte problems, you're going to get damage to those events. And you want your consumer to get that event, even if it's slightly broken, and then process it. So I bounced it back to the people that were writing this and said, can we have it as a blob as well? So there's another option within the actual APIs. And I'll show you some source code for this that allows you to just read it as a byte array. Because I say I'm a bit old school. I like just getting things as bytes and then just reformatting it myself. It's that old thing about genericization and specialization. I think I made up that first word. But in the old object-oriented days, you find a specialized person would write a bean that had get A, get B, get C. And a genericist like me, who didn't like writing too much code, would write a method that said get, open bracket, string name. And then in that, I'd say, if A, do this. If B, do this. If C, do this. That genericist approach is what led us to actually have the blobs in there. And it's really, really useful. So as I said, the nice thing about the PyLo can be unformatted. The attributes that are required, and there's a number of additional attributes that aren't required, but these are the ones that are required. You've got ID, which is the event identifier. That's contextual. So that's generated by the producer, consumed by the consumer. It's not pre-formatted. You've got source, which is the context, which is a URI. Those two are written by the consumer. This is the important thing. I'll jump over the last two first. I'll tell you the important thing about this. The ID and the source must be unique for each distinct event. So that's the identifier by which the broker decides that it's a unique event. So if you're writing a producer and you send the same ID and source combination, the broker won't forward it on to the triggers because it's deemed to be a unique event that's already been processed. So when I'm normally writing this and playing with it, I normally have a counter. So I have a URI which defines an identification contextually from the producer that produced it, and then a standard counter, so you never get the same ID. In terms of the attributes as well, you get the specification version. Again, the specification hasn't changed very much, but if you get a cloud event that doesn't match the specification version of the browser, it won't be handled. And you get type, which is a producer-defined event type. That's the important one. The ID and the source actually identify the event. The type is what's used by the broker to forward it on with those triggers I was telling you about. So a good old-fashioned example. I'm not sure if you can read that, and I'm happy if you can't. I don't like APIs because I'm old school. So what I did in this example was I simply built an HTTP URL connection in Java and dumped a post down the line. And you can see what I did was I just set request properties for the actual attributes. The C minus type is the type, C minus ID, spec version, source. Partition key was something to do with Kafka. I can tell a humorous story after if anyone's interested in why Kafka failed badly with that. And then all I've done is I've actually taken my object, which is called output. I've encoded it in JSON because I was, wanted to push it as JSON. And I've dumped it down the line as a post request. So in terms of using it, it's incredibly simple. If you can write a piece of code that produced a post request, you can generate a cloud event. I've actually got an application I'll show you, which I call the cloud event emitter, which allows you to emit these events to anywhere within the system. The broker is incredibly simple. And you can see from the YAML that actually defines it. That generates a broker. Now, the broker is a namespace-bound channel for siphoning and distributing cloud events. So for those who know Kubernetes and OpenShift, this is within a project, lives within a namespace. And it's namespace-bound. The broker has filtered subscribers to which it emits the events. So when you throw the event into the broker, it compares the CE type to the triggers it's got, and any trigger type that matches that CE type, the event is emitted to it. Under the covers, it's actually another post, but we'll pretend it isn't. We'll pretend it's something new and funky. But it is just an emit. The subscribers are set up using triggers which cater for one CE type. And that's one of the down things about the system at the moment. You can't have a trigger that looks for multiple event types, because event types are deemed to be unique. At some point in the future, it'd be nice to have multiple triggers to the same consumer, but we don't at the moment. And the brokers can be backed with technologies for persistence of events. As I said before, you can put Kafka on the back of the broker, such as when the event arrives, it can be persisted and then emitted, and then if you lose it, you can actually replay it through the Kafka side and regenerate it. More on brokers. Under the covers, the brokers can be reached if you don't use the Cloud Event API libraries directly as an internalized URL within OpenShift. This is the nice thing about it. And if you look at the actual format of the name, it's using the internal network.svc.cluster.local. All of the brokers are served from a central ingress point. Now, that can be deemed to be a bottleneck, but you can scale it and all the things like that. But if you look at the format of the URL, it's that ingress point, which happens to be the ingress point for the Knative eventing project, /target namespace /broker name. And it's that simple. So when I'm emitting things via an application itself, I just build that URL based on the namespace and the broker name. And the broker name's normally default because I don't bother changing it. And if you're a Luddite like me, you can simply send post requests to the broker directly. There are a number of APIs you can use for this. There's an API for Node, there's an API for Go, there's an API for Java. And that wraps it all in nice annotations and stuff. But because I'm so old and out of touch, I still think annotations are a new thing, which again means you shouldn't take my word for it. How a broker looks in OpenShift. I'll show you this running in the demo itself, but OpenShift actually renders it on the topology page as that thing on the left-hand side, this kind of binary broker. What you're seeing here is actually the demo I'm going to show you. The top right one is actually a CamelK integration that I've written, and that is driven by an event type. I think it's Tech Talk event. The bottom one, and if you can see the icon right at the bottom, that's a Knative function. That's the stuff I'm going to talk about how to build that very, very easily. That's a Quarkus function that uses a couple of the Quarkus libraries, and I won't spoil it because I use it as a pun on the next slide, to actually do the emitting of the cloud event and the processing of the cloud event itself. You'll notice as well that both those applications are scaled down to 0. And that's the point behind this. Because they're Knative services themselves, they are not scaled up until an event arrives. And you get that wonderful efficiency when you're running this. You're not consuming any resources on the cluster itself until those events are actually pushed to the consumers. Getting funky with it, that pun actually hurt to type. Quarkus has a library called Funky, which gives you annotations within the Quarkus code. So you can do things like specify what cloud event it's going to be emitted. You can do things like automatic translation of the payload and things like that. Knative functions are a quick and easy way of writing and deploying resident-on-request and cloud event-driven microservices. And it wraps all the Knative wiring up for you. So you don't have to know Knative. You don't have to know the internalization of the Ingress points and all that kind of traffic analysis stuff. That does it all for you. And what I've got here underneath is the YAML that I use in the actual Knative function. So the Knative func command takes that piece of YAML and it converts it. And very, very quickly going through it, I've got name my function, namespace isn't listed, so I can just push it into whatever namespace is contextually active when I'm actually running it from the command line. The runtime is Quarkus. We've got a number of different runtimes for it. I love Quarkus because it's finally made Java relevant again, and love it to pieces. The image is where the KN function builds it to. So how it actually works is it uses a base framework image, which has all the framework you need to run the Knative service in it, the Quarkus libraries and all those kind of things. And it does a build of the actual Quarkus source code you give it and produces a composite image that it delivers to that image point. That image point is then used to serve the application into the Knative service that's running within OpenShift or Kubernetes. And you can see underneath I've got builder default. And what you have is a builder map that allows you to pull different framework images for building that function. Now, you don't have to know that. You can just go with default, which does a standard Maven build of the Quarkus stuff. But you can see from the third option, I think it is, that there's a native builder, and that's the Quarkus native build, where it actually does a native build, which makes it much, much faster. It compiles all of the stuff to binaries. And you've got the ability to put environment variables in there as well when you actually do the Knative function. I'll get onto it. There is a minor problem with that, but I'll tell you about it in a second. So wiring the services themselves to the broker, and this is the trigger stuff I was telling you about. The triggers are incredibly simple to write. And you can see all it does, you give it a specification for the broker you're going to use, and a filter, which is the attribute, which is the type, and the subscriber, which is the endpoint service. And the interesting thing is you look at the API version, it's serving.knative.dev. Even though this is Knative eventing effectively under the covers, it's using that service endpoint via the serving side. And that's the way it kind of gets around it. So when it gets the actual request itself, it compiles it into a standard service call, calls that service, that drives the creation of the actual pod. Writing Knative functions, you probably can't read that, which is good, but this is an example that's just got a couple of the Quarkus libraries in it. The interesting thing with this, and I remember I can walk around because I'm not actually wired to anything. The interesting thing with this is I've got an annotation called func, F-U-F-U-N-Q, and a cloud event mapping. Now, the reason I've got a cloud event mapping, because if you remember, I said the trigger, which actually maps the event into the Knative service, is abstracted. So the subscriber, the consumer doesn't need to know about this. But what this function is actually doing is receiving an event, and then it's emitting an event. And this is the key thing that makes it brilliant. This is why I get excited about this, because you could strip down an existing legacy system and build it as a number of microservices that call each other, because these microservices can actually emit the cloud events as well as processing them. And this is part of the demo I've got for you. So I'm using the func library to actually make this emit event. This is emitting an event of tech talk event. And all it's doing is it's just sending a bit of text down the line. So before the demo gods smite or smile on me, why this is huge for devs. I love the idea of functional decomposition and being able to break a system down. It's what we're meant to be doing with microservices in the first place. And we've done it to a certain extent. Lots of people do it, all this kind of stuff. We're limited with the ability of using microservices in Kubernetes because of that having to be resident all the time. So you get to a situation where if your system is made up of 100 microservices, you've got 100 separate pods. Or if you've got multiple replicas of those pods, you've got a huge amount of pods. And you get this kind of overhead of having to keep them up and having to keep them maintained and all those kind of things. So there has been some kind of fettering or control on the way that we can actually do functional decomposition. This gives us an excuse to do it right, because we can break things down into these very, very small microservices, and they're non-resident. So they're not taking resources all the time. So you could have 1,000, 10,000, 100,000 of these services on a much smaller cluster because they're not resident. So for me, that gets me excited because I'm thinking, well, I could write hugely complicated systems and not have a massive footprint on the Kubernetes and OpenShift side. But again, I haven't been a developer in Anger for 9 years. Why Knative is a choice of hosting? Again, that's what I was saying. It's an efficiency thing. You can get a lot more bang for your buck, a lot more of your services running in a much smaller area. And it just feels cleaner, feels way more efficient. And what future systems might look like? Well, you're going to get to a situation where you can functionally decompose these things down to very, very small microservices or just nano services. And you've got the ability to change them whenever you like. The one thing I didn't tell you about, which is really cool, is not only does Knative Services scale down, it scales up automatically. And I'll give you a good example of this. The demo we wrote for Summit involved taking a huge amount of events and processing them across 3 different clusters. So we were testing it by pushing 1 million events through at once. And the beautiful thing about the Knative services is not only do they scale down to 0, if they get a flood of traffic, these things auto-scale upwards. So the minute we were pushing 1 million events through the system, it was 10 pods, 20 pods, 25 pods, 30 pods, 35 pods, based on the traffic that was going through it. And that's done completely by default. You don't have to set anything. The Knative service will automatically auto-scale. And again, it takes me back to my excuse for actually using this in the first place. You don't need to know the technology. It simplifies it. But you're still getting all the power of this technology without having to know it, which I really like. I did take a couple of slides out because I was feeling a little bit guilty about them. And the slides I took out were the problems with Knative services. And as we're developers and we're all friends here, I'm going to tell you what the problems with the Knative services currently are. The first problem which we're currently working on is you can't use persisted volumes. Does everyone know what persisted volumes are? So persisted volumes are basically resident pieces of storage that you can attach to the back of pods. They're the things where you put the contextual information, so when your application is lost, it can restart instantly and still have the same information and context where it was. We decided not to use PVs or not to allow PVs with Knative services because of the rapid way in which these things come up and come down. I think that was a mistake. And the reason I think that was a mistake is because you're losing a lot of functionality. I'll give you a good example of this. I wrote a resident application that sat alongside the Knative services that was resident at all points, at all times, with the persisted backend storage on it. And I would actually call that directly from the Knative services. So when the Knative service was called, it would do a call into my resident service to store a piece of data. And it would do a call into the resident service to pull the piece of data. So it was abstracting the storage of it. But I then got the overhead of having a resident application for my storage engine. So, and the kind of sort of way to think about it nowadays is that there are ways to handle persisted storage, but you're not going to be able to do it directly within the Knative services themselves. It probably will come. When we get to a situation where the PVs can be fired up much quicker, then, yeah, they'll bring them into action. The other one is a slightly more interesting one, and that is that if anyone's played with Knative services, we have this concept of what we call a revision. And a revision is just another copy of the Knative service with a change to the environment variables or a change to the image that it's built from. These revisions are immutable. And what that means is when you create the revision itself with the environment variables, with the settings, you can't change them. So if you go and use kubectl or OCEdit or something like that, it won't allow you to change those things. It makes it physically immutable. The problem we've got is the kn function stuff, which builds these functions, doesn't cover all of the attributes that you can give to a Knative service. Now, that doesn't sound too bad, but one of the ones it doesn't cover is the default timeout. Now, what we mean by the default timeout is when you pass traffic into the Knative service, it will spin up. And then it waits for that timeout, and if it doesn't receive any traffic within that timeout, it scales down. And that timeout is currently something like 5 minutes by default. It's very easy, once you've created a Knative service, to create a new revision with a different setting for the thing, but you can't do it by default when you use a kn function. What that means in English is the first revision you actually deploy, if you want to add anything to it, you have to add another revision. That doesn't sound too bad, but when I was developing for the Summit demo, I created 400 versions of my app. And even though 399 weren't active, there were still Kubernetes objects for them. So when I did an OC get service or a kubectl get services, I had 400 services in my project. Well, they don't take a huge amount of space, but you're still filling up etcd. So it'd be nice if we could actually have defaults for the kn func to actually add those additional attributes that are not currently covered. Right, so let's see if the demo gods like me today. So, everyone see that? Too small? So this is going back to what I was telling you about. I've got a single namespace called Knative Demo in which I'm running these applications. I've got a resident application called the Cloud Emitter. It looks like this. It's a very sad 1996 style sheet that I still use 25 years later. And this allows me to actually put the broker address, the CE type, and the payload in and just emit it. There's a vaguely humorous story about this. When I started using Knative Functions for the Summit demo, they were still pretty basic and pretty early on in the development cycle, and there was no way to manually emit an event into the system. You had to write your own application to do a post or do these kind of things. So I wrote this application, I went back to the Red Hat engineers and said, isn't this cool? Don't you love it? It's sweet, I can emit events. And they went, yeah. And then they went and wrote an extension to the Knative function command to do it for you. And it was like, well, couldn't you have done that before? I wrote this horrible web page and had to show this horrible web page to people. But anyway, so what this allows me to do is to actually emit the events themselves. If we go back to the topology, well, I told you about the triggers, for example. So this is the broker. It's currently called default. There's nothing behind it, so it's that very simple piece of YAML. So it's just a channel throughput for the cloud events. If I click on the trigger, you can see this is trigger Quarkus. Subscriber is the Quarkus function, so it points at a Knative service endpoint, Ingress point, and it's filtered by type Quarkus event. Again, a slight bug which I've raised is if you've got multiple subscribers. So if you've got multiple endpoints for that, it only ever shows you the last one that was registered. So if I've got another one which is reading from the same Knative event, I'll only see the one that was registered last. What I've also got is a CamelK integration. So it's a very short piece of Java that I've deployed using CamelK. CamelK is a lovely wiring technology. But I just wanted to show two different technologies. That again has a trigger point. So that trigger point, which goes to the Knative service event reader, is of type TechTalk event. So what I can do, and I have to do a lot of quick clicking here to show you it. So if I go to the cloud event emitter, I've got a type Quarkus event, and this is the payload, and here is the content, and I can emit it. If I go back here very quickly, you'll see that this service is instantly starting. So that event has arrived at the broker's decided via the triggers which one to send it to, and it started that event. If I click on it, I can go and look at the logs, and you can see I've received the payload. So it's a very, very simple example, but you can see that the actual way in which that Knative function is driven by the event flowing through the broker. If I go back, you'll see that the actual CamelK has started as well. And the reason for that is that the Quarkus function, as I showed you in the example, emits an event. So when I sent that event directly to the Quarkus function, what it did was output the payload it got, and it emitted a TechTalk event back to the broker. That emitting the event back to the broker spun off the CamelK one. And if I'm quick, because I normally talk too much, and by the time I go back here, they've unloaded themselves, you should see at the bottom, message, hello DevOps, message created in the Quarkus function. So it's a very pithy example And a very simple example, and I wish I had time to actually write a more complicated example. But if you can imagine the kind of potential you've got with these kind of things, you can write an entire event-based system without having to learn the intricacies of Kafka and all that kind of stuff. Because you could focus on building the cloud events and focus on building the functions that actually serve them. And in the background, your infrastructure people can back the broker with Kafka. And you'll get all of the enhancements of Kafka, the replayability, the ability to use, I keep forgetting the word, I call them fragments, but there's another thing for them. It'll come to me in a moment. What was that? Sounds about right. I got one of those holes in my brain that I hear the word and it's like, that's the right word. And then 3 seconds later, it's like, what was the word? Oh, it's shutting down. So what you're seeing now, if we pop back to the topology, is that these functions are now winding themselves off. So what has happened is that timeout that's set for the Knative service has expired without additional traffic coming into the ingress point, and those have now gone away. So going back to what I was saying in terms of next generation systems, this makes it incredibly easy to build these microservices that don't take a huge amount of footprint. Now I can show you, I haven't prepared this, so you have to bear with me, but if I go to my terminal, and can anyone read that? And I'm hoping people say no. And the reason people say no, and I'm going to get shot by the people at Red Hat, is that I don't want Docker on my Mac. I don't like Docker on my Mac. My Mac's nice and clean. I like doing development on my Mac, and Docker seems to be a little bit naughty. So what I've got is effectively a Fedora virtual machine that I'm running on my Red Hat MacBook using VMware. Again, I hope there's no Red Hat people in the room that are going to be killed for that one. The reason I do this is the KN-Func stuff natively uses Podman or Docker. So you have to have Podman or Docker on your machine to actually do it. What I've got here is basically, if I cd into, wrong one. I know people you can't see that, can you? So if I do an alias ls equals ls to get rid of color schemes, that's better. So I've got a Quarkus function directory that's got all my Quarkus source code in it and the Maven file that actually builds that Quarkus thing. I've also got a CamelK directory which has my CamelK stuff in it. Because I'm nice and open, I'm going to show you what the CamelK looks like. And it's as simple as that, if people can see it. And what's lovely about this, because it's Camel, and Camel's nice for doing this kind of wiring stuff, from knative : event/tech talk event. And that's all I need to do in the Camel side to get it to be able to consume an event being driven by the broker. As long as there's a trigger that's actually connected to this, it'll actually send it across. But what's nice about it, when I use the Camel command line, which is K-A-M-E-L, can't even spell it, when I use Camel to run it, it automatically creates the trigger as well based on that. So that from knative : event/tech talk event actually physically creates the trigger for you. So all you need to do to actually play with the actual event you're getting is write code in the from stuff. So I've done something daft. I just .log received body, which just dumps it out to the log. But you could do anything in there. You could actually emit another event. You could call some standard storage and all that kind of stuff. What I love about it is that and I keep going on about this, but it's very, very easy to start with this. You're not spending your time worrying or having to think about how these things work. You can just go ahead and write the cool stuff you want to do. I want to show you the Quarkus thing as well. So I go into the Quarkus one. The interesting thing in here is I've got something called trigger function. And that might look similar. That's the trigger I've used. The difference between using the Camel stuff is when I actually do the KN-Func build, the KN-Func build will actually compile the Quarkus using the build file I've asked it to build. In fact, I'll show you that. If I do a cat on the func file, you'll see that what I'm doing here is I'm actually using the default builder. And the default builder is key.io/boson/FAAS-Quarkus-JVM builder. It's doing a JVM build of the Quarkus function. Boson is the upstream for Knative services. The reason I say that is that you don't need to know what the Maven file does, because that's all handled by the stuff that's running within the framework. In fact, if you've used Quarkus, which I'm assuming most people in the room have, go to the Quarkus website, choose Knative Functions, click on download, bang, generates this all for you. And you can just focus on actually writing the source code. And if I go to the source code, Java, it's beautifully simple. Beautifully simple. So what you got here effectively is we got an @func annotation and an @cloud event mapping response type equals tech talk event. And I'm using Uni, which is part of Mutiny, I think, off the top of my head, to actually asynchronously push that cloud event. So you can see what it does is it does this. Return uni.create from emitter, build response, input cloud event emitter, which calls build response here. Build response just builds the output packet and pushes it to the emitter. So again, the boilerplate you've got in there is very simple, and you get it all written for you by the Quarkus website. And that's what I love about it, because I don't know about you, I've spent too much of my time writing bad boilerplate that doesn't work, and I've had to debug boilerplate as opposed to debugging my source code. So, I mean, the main message, which I've probably said a number of times, is that this is just so easy to use and so powerful at the end of the day. The problem I've got with it is that people aren't using it at the moment. And I think people aren't using it because they're unaware of it. You know, I only became aware of it because I was involved in the Summit demo, and I didn't even know Boson existed as a project at that point. But this, to me, is incredibly powerful. And if I had more spare time, I'd be writing all my systems like this. That was basically it in terms of the demo and the presentation. As my Red Hat colleagues normally say, I mean, feel free to ask me any and the hardest questions you possibly can. Unusually, I'm not hungover, so I might not be able to answer them, because I can normally answer them when I'm terribly hungover. Not being hungover means I've got a lot more stress, so I probably won't be able to answer them. But anyway, has anyone got any questions? I don't know how this works. So can CamelK be used to write messages to a database? Yes. There's a number of different extensions within the roots of CamelK which are already there. The lovely thing about CamelK is it comes with a number of packed integrations. I had another example which I used beforehand, and I was using the CamelK route for Telegram. So I was pulling Telegram messages off of a Telegram channel and actually processing them as a Knative service and playing around with them and pushing them out and stuff. Used it on a Telegram channel at work and then was told off because I come from a background of snooping. So they saw it as me sort of monitoring what people were doing. I shouldn't have called it Watchman, which was the big giveaway. But I also wanted to call it Nanny Bot, but they didn't like that either. But yeah, you can use any of the integrations that are currently offered through the Camel side. What I've done with the database side in the past is I've actually done Quarkus. And I've used things like JDBC and Hibernate directly from within those to actually talk to the database itself, but you can use it within Camel. Lovely stuff with the Camel, lovely side of the Camel stuff is that, as I showed you, it's like 2 lines of source code. And I just use Camel Run. There's no compilation. It just builds the integration within the actual OpenShift platform itself. And it's much, much quicker to actually develop and push out. Does that make sense? Any other questions? Over there first.
To test your application you're building, do you need to spin up an OpenShift stack or a Kubernetes cluster? I'm accustomed to using Docker or something like that for my test doubles and things like that. How do I go about testing my application?
You can use Docker, you can use Podman, you can use whatever you like. The only thing to be aware of is if you're using Docker and Podman and not using Kubernetes and OpenShift, you're going to have to simulate the cloud event stack, the way in which the cloud events are actually emitted into the system. Because what it's doing under the cover is building the cloud event, it's actually doing a post and all those kind of things. So you'll have to build a harness around it and simulate the broker. But that's the only thing you have to do. To be honest, it's much easier to go down the OpenShift and Kubernetes route because it's all done for you. You don't have to build your own test harnesses. But no, you don't have to use Kubernetes or OpenShift to actually test these things in anger, if that makes sense.
Yeah, that makes sense. It's just, I've used CRC in the past, it's fairly heavy in the last.
I'm not allowed to comment. No, I am allowed to comment. I'm not a fan of CRC, and I'm not a fan of CRC because it's a wonderful technological experiment to try and squeeze the whole of OpenShift into a single virtual machine. But what you're doing is you're giving people the impression that OpenShift is slow. because the CRC performance, you really need a grunty laptop to do it. And I've had too many people I've talked to that said, we tried CRC, and we tried to run a couple of things, and it was just so slow that we think OpenShift is so slow. And it's like, no, stop, please. OpenShift's an enterprise system that you can run on multiple nodes with huge amount of RAM and all this kind of cool stuff. But you could use CRC. But yeah, does that answer your question? Any more questions? I can't see anyone at the back.
You told that if there is invalid input, yeah?
Yes.
And now it processes and it commits, it presents some messages, yeah?
Yeah.
But that becomes an unwanted message, isn't it? We don't know what it is, and it can even bring down the service, isn't it?
Well, I think it's.
Does it give a warning or something like that?
It doesn't. I mean, that's well, no. This is a very good point. The point was what happens when the message is corrupt.
Yes.
Yeah. This is what I've got a problem with. The problem I've got a problem with it is that these things are transient. The actual functions themselves are transient. So if you throw a message into it, and I fell foul of this. If you throw a message into it when you're using JSON, the first thing the underlying API does is it puts it through the JSON translator. I can't remember what it is. Jax something or other. Jax B or Jackson. Yeah, I think it's Jackson. Puts it through that. If it fails, it throws a stack trace. That stack trace stops the processing of the actual message. The problem is this. That service goes away after the timeout. And when it goes away after the timeout, you don't have the logs. One of the things that I did to actually test this was I wrote another application, again called Watchman. And what Watchman did was Watchman allowed you to persist the logs. And so what was happening when the message failed, and it just basically shortcutted and dumped the stack trace, in the catch, I actually wrote out the information that was in the exception to Watchman, who was persisted, who stored it in a persisted volume. That's a lot of overhead. And that's why I went back to them. I said, can we have it that the payload is not automatically processed? Because what it does at the moment is it tries to identify what's in the payload. If it detects JSON in the payload, it automatically pushes it into the Jackson. If the Jackson fails, it shortcuts and dumps the thing. That's why I asked it to be in byte. So what I've got is all my functions that actually consume the cloud events take as an input byte, square bracket. And then I decide whether it's a JSON, and I do the JSON processing, and if the JSON processing fails, I can still partially respond to it. But that's why I raised it with them in the first place, and that's why we've now got the ability to have flat byte payload. But I'm old school. You know, I just don't trust things.
It should say a warning, isn't it? Yeah.
Yeah.
Does it raise a flag or something saying this is correct
Nope.
data?
Nope. It's because it's behaving as expected. It's throwing an exception in the actual JSON processing, and it knows that when it throws a JSON exception, it needs to stop because the JSON isn't formatted correctly. And it's that kind of automatic assumption that every message you're going to send is valid JSON. And it's great in a production system where everything's defined and everything's working. But when you're trying to develop this damn thing, you know, this thing's failing left, right, and center, and all you've got is an empty circle and no logs. And it's like I don't like JSON. Sorry. Did I say that out loud? Anyway, any questions? Oh, sorry.
So my question is about broker scalability.
Yeah.
Because Kafka is incredibly scalable.
Yeah.
So here we have, as far as I understand, excellent consumer scalability because you spin up consumers on demand. But what about broker scalability? Will it become a bottleneck? Have you tested how is?
We have tested this to destruction on the Summit demo because we had a Kafka backing on the brokers we were using. And we wanted to take advantage, as you said, of the scalability of Kafka itself. What's nice about it is the broker is basically a transparent layer over the top. Underneath, you can do auto-scaling of the Kafka stuff. The broker is actually a single point, but what's nice about it is the broker doesn't exist. The broker is just internal wiring from service to service to service. With the scaling of Kafka, you can actually have multiple Kafka backends with multiple, what's that word again for the partitions? Is it partitions? Wow, it's stuck. I've learned something today. We had multiple pods based on partitions, and we had them on different nodes themselves, so we could scale them up and down and all these kind of things. No impact on the broker whatsoever. The broker was still a single endpoint, effectively. So you can take advantage of that. So it's massively scalable at the broker point and at the application point. I tend to use ephemeral ones because I don't understand Kafka. If you're talking to any sane person who's like 20 years younger than me, they would love Kafka and all these kind of things. Does that make sense? Cool. There was a question there?
Yeah, my question was about the consumer. There is a way to, let's say, maximize the number of consumers and to check the back pressure there.
Yeah.
And also, what is the performance that you need to have in your image to run very quick to at least to speed up the application?
That's a good point. So it was basically what we do in terms of auto-scaling of the application itself and how we make it load fast. Is that fair enough? Yeah. So one of the nice things about this, and one of the things that made me laugh about the Summit demo we did, is that even though you can scale it down to 0, you can set the automatic number that you want to have. And what that means is, when we first ran this up, when we were putting 1 million events through it, we found that the time to spin up the individual copies was having a bit of a hit on the processing, which was actually backlogging the Kafka stuff. So what we did when we defined the functions, we said, right, when this function is deployed, automatically have at least 100 replicas. So you don't have to, if you don't want to, take advantage of the Knative scaling down to 0. So when I was running these as part of the Summit demo, these functions were actually firing up with 100 replicas. And then when it was getting loaded on top of that, it was loading more and more and more. Now, in terms of the speed of actually creation of them, there are some tricks. Because what you're seeing when you actually deploy an event in the first place, the lag you get, because you do get a lag when you first deploy it and you first call it. And the lag is down to where the pod is. So if you're running this Knative service and it fires up 1 replica, and let's say you've got 4 worker nodes, Kubernetes is Kubernetes. It decides, I'm going to put it on this node over here. So it'll dump it onto there. If it auto-scales, it might put it onto another node where the image is not resident. So that image has to be brought in from the integrated registry to the node. And then what you're seeing with the lag is actually the image being distributed to the additional nodes. So one thing we did to actually make this performant in a production way when we were doing the demo was when we actually started it, we front-loaded it as part of the test. So we'd install the Knative service, and then we'd thrash some event messages through it. And what we made sure was that at least 1 copy of every single replica landed on one of the nodes. So every single node had the image preloaded. When the image is preloaded on the node side, the startup is instantaneous. That's the nice thing about it. It is cold offline, but it's still an active and resident image on the node, so it doesn't have to go back to the central image registry to pull it. So if you want it performant and you want it to have no lag on the actual Knative services themselves, when you do the first installation, either set the initial replicas to something like 10, and what will happen then is it will drop it onto, if you've got, let's say, 6 nodes, set it to 6, whatever, set it to that. When it first does an install, it will drop 1 on every single node, shut them down, and then any call to any of those nodes will get an instantaneous restart. That makes sense? Any other questions? I say I can't see because of the light. There's a question right at the back, I think.
Is there support for sidecar containers?
No. It's the only reason I could answer that so quickly. So the question was there any support for sidecar containers? The only reason I can answer that so quickly is that this does not play well with Istio. And of course, Istio has the face huggers, those containers that sit on the side of all of your containers and just abstract it from the thing. It's one of the things we're currently looking at, adding sidecars and adding init containers to it. The reason we haven't gone down that route at the moment is that the traffic, the way in which the network traffic gets into these applications is already slightly verbose, because all of this traffic has to come through the Knative eventing initial ingress point before it goes somewhere else. If you've got sidecars on there, you've got the additional time of spinning up the sidecar container. I do know that they're currently looking for the next release to allow Istio. In fact, they might already allow Istio or Red Hat Service Mesh with it. If they've done that, then sidecars will be available. Does that make sense?
Yep.
Cool. Any other questions? I think I've got 2 minutes left.
Is it Ingress thing, is it pluggable? Can you put any Ingress controller? Or it's only a thing that comes with like OpenShift or comes with
You can put any Ingress controller as long as that Ingress controller pushes the traffic into the Knative eventing, Knative servicing.
requirements? What's so special? Is it special annotation needs to be there? Or
you can treat the Knative eventing entry point as any application that's within OpenShift. Any application within OpenShift, you can add your own custom Ingress controller to it. It's one of the features of it. And that custom Ingress controller just pushes the traffic into the SDN at the correct point. if that makes sense. So you can do that. You're going to get the overhead of having to maintain an external custom Ingress controller. But it doesn't, it's not something you can't do, which is a very bad way of saying yes. Yeah, I got to the end of that sentence and thought, why the hell did I say it that way? Does that make sense?
I have a small doubt actually. So if it's got the zero scaling,
Yeah.
say there is a microservice, when the request comes again, so it has to come up and serve, so it will take more time, right? So there's latency will be affected.
No. No, this is very similar to the question that was asked earlier. What it is basically once you've instantiated, sorry, it's flashing times up at me. What's that mean? Once it's actually instantiated that service on each of the worker nodes, the restore speed is very, very, very fast. Very fast indeed. What we normally find, being brutally honest about it, is it's more to do with the way in which the application is working within the pod, not the spinning up of the image. And this takes me back to it very, very quickly because I'm getting flashed at. If you take a Spring Boot app, if you run up a Spring Boot app in Knative Services natively, it'll take 30 to 40 seconds to restart that Spring Boot app because the framework itself takes 30 to 40 seconds to start. If you rebuild that with Quarkus, it takes nanoseconds. And it's all to do with the class loading. Because if you notice, I was building the Knative service as part of Quarkus. One of the options was to build it native. If I build it native, it pre-compiles all the classes into a binary, which means you don't get the class loading overhead, which is why your 40 seconds of time to start comes down to nanoseconds. So the 2 points are to look at the speed of startup of your application itself and write it more like a cloud native one, or use Quarkus to do it. So where I'm at, I assume I'm out of time because it's flashing and telling me off. Does that mean I'm out of time? Yes. Cheers, thank you.